Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Vocational Education and Training, SOVET, Master's Degree Programs, Master of Science, Information Security, MSCIS, Semester 4, MSE 033 Web Application Testing and Audit, Block-1 Web Fundamentals and its Security, Unit-3 Web Application Architecture, 1.1 Introduction to Web Application Architecture. A web application is a software that runs on a browser. In simplest forms, it addresses a particular problem and is used to find some information. It is an interactive program that runs on a web browser and has a content management system on the server side. Web application architecture is a model that demonstrates how web application components interact. These web application components interact with each other: simple web pages, user interfaces, middleware systems, and databases. These interactions are necessary to build a system by integrating various applications and using them simultaneously to serve a purpose. For simple websites, when a user opens a web page in a web browser, the web server interacts with the user. The user requests the web server to send a specific web page, and the web server builds the web page and sends it back to the user's browser as a response. The user's browser acts as a web client or user agent and sends requests to access web resources. These web resources are called web documents, which can be HTML pages, JSON, PDF, and so on. Requests to access these documents are sent to the web server. In response to these requests, the server sends the required documents to the web client, which is then displayed on the client's browser. This interaction continues as the web client generates more requests and the web server responds. A web application is designed to meet a specific need and goal and functions efficiently. Web application architecture is critical since web-based communication is used in every single app and device and is used in most global network traffic. Web application architecture deals with the system's scalability, efficiency, robustness, and security. Figure 1. Web application components. Look at the screen. Web applications have three main components: the client side, a web browser. The user interacts with the web application using the web browser only, and it serves as a medium to control the communication between the user and the application. The client-side applications are usually coded using HTML, CSS, and JavaScript. The server side of the web application acts as a central hub. The server hosts multi-tier services and completes the web application's business logic. It is designed to implement the rules and constraints on the data flow in all the operations done on the server side. The server-side application is usually developed using some popular application programming languages like PHP, Python, Java, .NET, and Node.js. The database server application is part of the server-side application, which holds all the databases required to be stored and processed for supporting business logic. 1.2 Website versus web applications. A website provides text and multimedia content requested by the user, and the user can display it on its browser and read it. On the other hand, a user interacting with a web application can not only read the page content but also manipulate the data on this page. The user interaction with the web application is in the form of a dialogue. The user interacts with the web server by clicking on the buttons or submitting a form, and the server responds to the requests made by the user. This response is in the form of a document download, electronic payment, online chat, and more. Sometimes other software like CRM, ERP, etc. is also integrated with websites and web applications. This integration helps in supporting the complex functionality of web applications. Most web applications require user authentication, as web applications offer a much broader scope of options than websites. User authentication is not mandatory for most websites. For web applications, the users are usually offered to first register and then gain access to additional options and features that are unavailable to unregistered visitors. For example, if you are visiting a news website, you can go through the news articles and featured articles without registering yourself on the website. However, if you want to write feedback or participate in a survey conducted by a website, you will have to register and log in. 1.3 Why is web application architecture important? Web architecture can be considered a blueprint for supporting the future growth of web application arising from increased demand, future interoperability, and enhanced reliability requirements. It is imperative to have a good web application architecture because it precisely defines how web applications will function. Some features of web application architecture include delivering persistent data through HTTP. Dialogue between client and server ensures that the requests contain valid data. Option for user authentication limits what users can access and manipulate based on access permissions, creation, updations, and deletions of records in the database. To have a good web architecture, some of these attributes are necessary. It is as simple as possible. It solves problems uniformly and consistently. It has implemented the latest standards. A/B testing and analytics. It offers quick response times. It implements security standards and measures to reduce the chance of malicious penetrations. Application does not crash both on lighter load and heavy load. Application can heal itself. There is no single point of failure in application. Application easily scales out. Known data are easily created in application. Errors logging is implemented in a user-friendly way. Easy and automated deployments. 1.4 Software architecture and software design. Software are made up of many different components, and its design is complicated. Among these components, two important components are the development of software architecture and design. These are two critical stages of software development and are often confused. In the software architecture design stage, the software characteristics are transformed into a well-structured solution that fulfills the technical and operational requirements. Some of the important software characteristics are security, scalability, flexibility, and reusability. Software architecture aims to develop a high-level infrastructure design and framework for the target software. In contrast, software design only concentrates on code-level design. It addresses problems like the scope of classes, the purpose of associated functions and methods, the functions of individual modules, and the like. During the software design stage, a design plan is prepared that delves into the different modules of software that make up a software system. Software design also elaborates on how these modules work together to fulfill the system requirements. While developing a software design plan, designers must negotiate system requirements and expectations with customers and stakeholders. Stakeholders are persons from direct management or the marketing team. Once prepared, the design plan becomes a reference document throughout the software development process. This is treated as a blueprint that guides the software development teams during the design and implementation of various development tasks such as coding, design, integration, and testing. The software design plan is next to requirements analysis, risk analysis, and domain analysis. User and system requirements, once identified, are transformed into implementation during the software design stage. Once completed, The software design process produces the following artifacts: Software Requirements Specification, SRS. SRS is a document describing the desired behavior of the system under development. This document is prepared during interactions with users and elaborates on functional and non-functional requirements, hardware platforms to be used, and interaction of the target system with other systems. The requirements listed in SRS should be actionable and measurable. They also need to be traceable to corresponding business requirements. High-level design. System design is now fragmented into more specific views of modules and subsystems. The high-level design focuses on implementing these modules and their interaction with one another. Detailed design. This artifact is also produced during the software design process, and it contains a detailed system design that delves into the problem of implementing the modules. A detailed design document defines the logical structure of every module and lists the interfaces supported by each module for interacting with other modules. Each of the above-mentioned principles is derived from battle-tested ways of developing software. For example, there is a principle called single responsibility principle, which ensures that every class has only one responsibility. Another principle, called the interface segregation principle, states that code should be structured to ensure that a function in a class is implemented only if it is essential for its purpose. Otherwise, the class is not forced to implement non-essential functions. This concept is the basis for categorizing interfaces. Software architecture documents are considered a blueprint for any software system. These documents are used to manage the system's complexity and suggest the coordination and communication among various system components. Software architecture is a well-structured solution for the proposed system, and it meets the business and technical objectives and any optimization issue like system security or system performance. Once software architecture is ready, the development team is at a level to make some decisions about the software development process. Some of these decisions are selecting the structural components and related interfaces which make up the system, defining the behavior, collaboration and communication between these components, integrating these structural and behavioral components into a larger subsystem, deciding architectural styles which may guide the organization, alignment of the architecture with organization's key business objectives. All these decisions have a significant impact on the quality, performance, and maintainability of the software system. Ultimately, software architecture plays a big role in the success of the final software product. The main goal of any software architecture is identifying the system requirements that will finally influence the structure of the software application. Software architecture considers both the functional and quality requirements of the target software application and eventually improves the overall functionality and quality of the software system. A well-developed software architecture reduces the risks associated with building a software solution. It helps in closing the gap between the business and technical requirements. By realizing all use cases and business scenarios, software architecture addresses the requirements of all stakeholders. 1.5 Components of Web Application Architecture. The web application architecture is a layout demonstrating the interactions between various components of web applications, user interfaces, middleware systems, and databases. The complete architecture of various components and interactions between these components and applications displays how these components and applications work together to achieve the desired goals. In a web application, when a user interacts with an application using a web page, the server responds by sending requested data to the user's browser as the user makes a request through the browser. The user is acting as an agent or web client and generates requests for web resources or web documents, e.g. HTML, JSON, PDF, and so on, through a web server. Figure 2. Web application architecture. Look at the screen. Then the response generated by the web server is displayed on the user's browser with minimal manipulations. Now user starts interacting with the website. Web application 1.5.1 Domain Name System DNS. Domain Name System DNS is like a telephone directory that helps search a domain name and its IP address. Humans browse the web using domain names like www.espn.com. The request goes to DNS to find the associated IP address hosting this website. The DNS server provides the IP address in response to the request, and the browser uses that IP address to access web resources. Each device interacting on the Internet is assigned a unique IP address which is used by other machines to identify the device. Remembering these IP addresses is difficult, hence DNS servers are used to eliminate the need to memorize device IP addresses such as 192.168.10.1 in IPv4 or more complex newer alphanumeric IP addresses such as 1300 CC00 2048 1 B523 D8B3 in IPv6. 1.5.2 Load balancer. Load balancer distributes the load to multiple servers, and this feature is known as horizontal scaling. Load balancer directs the incoming requests to one of the multiple servers and finally sends the response generated by the server to the user. Multiple servers, in the case of web applications, are known as web application servers, and these can be in the form of multiple replicas which mirror each other. Request forwarded to any of these replica servers is processed in a similar manner, and it is the responsibility of the load balancer to evenly distribute the tasks among these servers to make efficient utilization of all servers. 1.5.3 Web application servers. These are clusters of servers that accept users' request for web resources services and sends requested resource response in form of web pages back to a browser. These servers are referred to as backend infrastructures, which consist of databases, cache servers, job queues, and others. If the load balancer is deployed on the server side, two or more servers accept and process the user's requests. 1.5.4 Databases. As the name suggests, a database stores complete data related to web applications. A database supports operations like add, search, update, delete, and compute. Usually, web application servers are directly connected to database servers. 1.5.5 Caching service. Caching service in web application infrastructure provides temporary storage for data during storing, updating, or searching. Whenever the server generates a response to the user's request and some data is generated by servers, this data goes to the caching system. This caching of data makes applications faster and eliminated unnecessary delays. This means users can refer to the previous results and make computation much faster using these caching services. Caching is very effective when the computation is very slow compared to the response from the server. A computation is likely to be repeated when identical results are generated for future requests. 1.5.6 Job queues and job servers. This component is optional in web applications. The job queue section in web applications has two components: the job queue, which stores all the requests, and the servers to serve the requests in the queue. These servers process jobs in the queue. It happens that most the web servers need to operate a vast amount of jobs that are not of primary importance. Therefore, When a job needs to be fulfilled, it goes to the job queue and is operated due to a Schedule 1.5.7 full-text search services. Most of web applications support text search functions, which are executed on user request. The server searches for relevant results, and then the web application sends the result which is most relevant to a user. This feature is known as named full-text search service. Using user-provided text keywords, the web server performs a search among a vast number of documents. 1.5.8 services. When a specific level of design of a web application is achieved, some services are added in form of separate apps. These services are usually not visible to existing web application components, but these services and web applications interact with web application components. 1.5.9 Data warehouse. Almost all modern web applications deal with large amounts of data by collecting, storing, and analyzing the data. These data handling processes need to be implemented in 3 stages. 1. The data is sent to the data firehose using a streaming interface which results in the absorption and processing of data. 2. Raw data, processed data, and additional data are then sent to the cloud storage. 3. Finally, all processed and additional data also go to a data warehouse. A data warehouse is a facility for the online storage and exchange of data through the internet. The data warehouse can also store other types of files such as videos, photos, and so on. 1st May 2010 Content Delivery System (CDN). Content Delivery System is responsible for generating and sending HTML, CSS, JavaScript, and image files. It delivers these content types available to the end server throughout the world, so the users can load and view desired information on their browser. 1.6 Models of Web Application Components. Web application components are having 3 models which are closely related to the number of services and databases used for a web application. 1.6.11 Web Server, 1 database. In this model, a single server and a single database are used to serve the user's requests. But this model is the least reliable out of the 3 as a single server may go down, interrupting the web services. Hence, this model is rarely used in designing web applications, but still, this model can be used to run test projects and understand the web application's functionalities. 1.6.2 Multiple web servers, 1 database. This model has quite an interesting feature as it does not store any data. When a user agent sends information to the web server, it processes it and then sends processed information to the database. Data management is done outside the server. Multiple web servers and 1 database model is called stateless architecture. We need at least 2 servers to implement this model. Multiple servers are essential as the system becomes more reliable. If one server goes down, another one will take complete charge. Using a load balance, when all servers are active, requests are divided among these servers, but in case of failure of one or more servers, all the requests are automatically forwarded to the remaining working servers without interrupting the functioning of the web application. However, the use of a single database makes it less reliable, as applications will crash if the database goes down. 1.6.3 Multiple web server, multiple databases. This web application model is the most efficient and reliable model among the 3 models. The obvious reason is the use of multiple servers and multiple databases. There are 2 ways of storing and retrieving data from databases. The first one is to store data in all accessible databases, and another one is to distribute the data among multiple databases. In case of one database failure, the web application will not crash as other databases are available to serve user requests. However, if you opt for the distribution of data among databases, it is possible that some data is not accessible in case of database failure causing a database crashes. 1.6.4 Application Services. 3 web application models discussed above are so-called monolithic models due to their servers' rigid and stable nature. In contrast, application services, microservices and serverless tend to be agile since they simplify upgrades and scaling. To implement multiple server models, you need to split up the web servers into smaller parts called services in microservices and functions in serverless. Thus, modifying and scaling these servers independently is quite easier. 1.7 Types of web application architecture, however, blurred the line between front-end and back-end development. Web application works with them both. Let's go into their types separately. 1.7.1 Front-end. 1.7.1.1 Single-page application, SPAS. Single-page applications, SPAS, facilitate programmers' work. In response to the action by the user, whole page contents are not loaded again from the server. Instead, the server and user browser interact by receiving updates of contents for the current web page. In such type of web application, the web design architecture is created in a way that most necessary web page content and data are requested first. SPAs do not interrupt users' activity and provide an intuitive and interactive user experience. JavaScript is the most preferred web development tool for this type of web application architecture. 1.7.1.2 Server-side rendered application, SSR. A client-side JavaScript framework website is rendered to HTML and CSS on the server in these types of web applications. Using SSR, it is possible to quickly deliver the most important assets and accelerate the browser's speed as rendering the page to the user takes less time. When an SSR application is built, the server compiles all the data and serves the user by sending a new HTML document on each request. When the user browser gets the CSS, it simply paints the user interface on the screen, and the user browser need not wait for JavaScript to be loaded. This way, SSR makes the loading of the page faster. 1.7.2.1 Microservices. Microservices are treated as a type of service-oriented architecture, SOA. Generally, these microservices are designed to execute a single functionality and deal with only small and lightweight services. Thus, this microservice web architecture design is more efficient and productive. Web development is faster and saves much time for web developers using microservices. All components of a microservice are not built using the same web development language, and they are not interdependent. The advantage of this it means that developers are free to pick a technology they prefer, which as a result makes the microservices architecture development quicker and easier. 1.7.2.2 Serverless architecture. From the name, it seems that this web application architecture is without servers, but this is not true. Serverless architecture implies that management software is not necessary to configure and administer web servers. The entire server infrastructure requirement is outsourced to a third-party service provider. In serverless web application architecture, the app developers need to consult a third-party services provider supporting cloud infrastructure for outsourcing servers as well as other IT infrastructure management. If an organization is not capable of managing and supporting server infrastructure and related hardware, the serverless architecture is the best choice for these organizations. 1.8 How web application architecture works. 1.8.1 Best practices and trends in web application architecture. Any web application architecture needs to be straightforward and efficient and should ensure smooth development and maintenance of web applications. High-level web application architecture supports easier extension and modification of the application, and it also helps in testing, debugging, and comprehension. Following are some best practices and trends for building a reliable application architecture: flexible, efficient, reusable, simple, easily testable, with well-structured and understandable code, solves problems consistently and successfully. Scalable in the development process, fast response times, doesn't crash, doesn't have a single point of failure, uses go-to security standards. The success of a web application is closely connected to its architecture, fast and secure. Web-based communication for users. A web application can also work perfectly even without a good web architecture, but it'll be head and shoulder above other web applications with precise architecture. 1.9 Discuss about some web application architectures. 1.9.1 Java Web Application Architecture. The Java Web Application Architecture is very versatile, and because of this versatility, it is traditionally been a favorite in the enterprise web development environment. Currently, Java Application Architecture is the undisputed top player among the most favored web development programming languages. The complexity of web application architecture depends solely on the requirements of the desired solution. Java Web Application Architecture technologies are well suited for simple informative web applications as well as robust and complex multi-tiered web applications. A large number of Java native web development tools are available which can be combined to build a web application using Java Web Application Architecture. Developers can pick and choose from a wide array of available Java products and frameworks to create everything from simple web applications to full-fledged enterprise-wide systems. Figure 4, J2E Web Application Architecture. Look at the screen. 1.9.2 Cloud-based Web Application Architecture. A cloud-based web application, or cloud app, is a web application where cloud-based components and local components of a web application work together. This web application architecture relies on remote servers for business logic that is accessible through a remote web browser connected to the Internet. 1.9.3 Mobile Application Architecture. Mobile application architecture is used to develop fully structured mobile applications. This architecture consists of a set of patterns and techniques which mobile app developers need to follow. The techniques and patterns are developed to meet the industry standards and vendor requirements. A mobile application architecture is divided into several layers, namely the presentation layer, business layer, data layer, and user experience. Architecture plays an important role in developing a mobile application. Following are some important aspects of the mobile app you need to keep in mind while building the mobile app architecture. Features of the mobile device. It is important to consider the features of mobile device, such as screen size and its resolution, CPU characteristics, storage, memory, and availability of development tool environment. Some of the features in the target application might have special requirements from hardware or software. So we need to know the hardware and software features of the device before building the app architecture. Considering bandwidth, the app architecture is built to work in the worst network scenarios, as there are situations when internet connectivity is either intermittent or not at all available. We need to design caching and data access mechanisms and decide on state management considering intermittent internet connectivity. Batch communications and the selection of software and hardware are based on it. Defining user interface. You have a big space to show your creativity in the user interface. do not pour all your creativity into the very first stage. Try to keep the user interface as simple as possible. It has been noticed that a muddled user interface becomes a major reason behind the failure of mobile applications' navigation methods. This one again comes on the design front. However, it requires expertise in both the front and back end. There are numerous ways to navigate through app features. It is important for you to analyze which one's good for your mobile application. The list includes single view, stacked navigation bar, tab controller, gesture-based, scroll views, search-driven, model controller. Choose the navigation method after understanding its users and the app requirement as it directly affects user experience. The app architecture designing process has to be executed in a defined flow, which includes 3 different layers, namely, presentation layer. This layer includes the user interface for views and related process. Components, controllers. While defining the architecture of this layer, the design team has to define the front end of the mobile app. The designer primarily focuses on deciding the features and the location of user interface components. Other aspects of the user interface, like the theme, font size, etc., are also decided business layer. In this layered design, the focus is on the business front. The designer focuses on the way the business logic of the app will be presented to the end users. The business layer describes workflows and contains various business components and entities, above 2 sublayers named service and domain model layer. The service sublayer defines a common set of application functionalities that are to be designed and made available to the end users. The domain model sublayer defines the expertise and knowledge linked to the specific problem domain. The entire business layer is designed to explore and enhance the web application in the future. Data layer. At this layer, factors related to data and knowledge are kept in mind. This includes components for data access, data helpers utilities, and service agents. These 3 components sit under the 2 subheads called the persistence layer and the network layer. The persistence layer ensures simplified access to the data, which are stored in persistent storage or backend. The network layer is responsible for all networking calls. Once the 3 layers are designed properly, the developer focuses on cross-cutting, which is the 4th participant here. This component takes care of security, configuration, and communication connectivity. After successfully designing all these layers, one can expect the completion of a better mobile application architecture. However, if it is required to cater to other operating systems like BlackBerry or Windows, then one can go for a cross-platform development tool, which could turn out to be cost-effective. However, there would be a compromise on usability. Another available option in this scenario could be to go for web development as well as native development. These 2 can complement each other and help you in a better engagement of both customers as well as employees. 1.9.4 Node.js Web Application Architecture. Node.js is a JavaScript-based web development platform primarily used to create I/O-intensive web applications like chat apps, multimedia streaming web applications, etc. It is built on Google Chrome's V8 JavaScript engine. The web application runs on a server and is rendered by a client browser that accesses all of the application's resources through the internet. Web application consists of the following components. Client. A client refers to the user who interacts with the server by sending out requests. Server. The server is in charge of receiving client requests, performing appropriate tasks, and returning results to the clients. It serves as a bridge between the front end and the stored data. allowing clients to perform operations on the data database. A database is where a web application's data is stored. Depending on the client's request, the data can be created, modified, and deleted. Node.js server architecture. Node.js employs a single-threaded event loop designed to handle several concurrent clients. Node.js processing model employs two types of mechanisms: the JavaScript event-based model and the JavaScript callback mechanism. I/O functions are implemented using either an asynchronous model or non-blocking of I/O operations. These features enhance the scalability, performance, and throughput of Node.js web applications. Components of the Node.js architecture. Requests. The requests to the server can be either blocking, complex, or non-blocking, simple, depending on the actions that a user needs to perform. Node.js server. The Node.js server accepts user requests, processes them, and returns results to the user's event queue. All incoming client requests are stored in the event queue and later passed sequentially to the event loop thread pool. Node.js server contains a pool of threads which are available for performing server operations required to process client requests. Event loop. Event loop receives requests from the event queue and sends out the responses to the client's external resources. In order to handle blocking client requests, external resources can be used. They can be of any type: computation, storage, etc. The Node.js server can efficiently handle a large number of requests by employing the use of event queue and thread pool. There is no need to establish multiple threads because event loop processes all requests one at a time, therefore a single thread is sufficient. The entire process of serving requests to a Node.js server consumes less memory and server resources since the requests are handled one at a time. 1.9.5 Python Web Frameworks. For many web developers, Python frameworks are the most preferred frameworks. Like other web development tools, a large number of Python frameworks exist, and these frameworks make the web development task quite easy. Python web development tool is one of the most popular and powerful web development tools that are available for software development. It is one of the best choices for developing web applications. The simplicity of Python programming language is the main reason behind web programmers' interest in Python. The Python language community is huge and major updated versions are available now. Here we discuss the latest Python 3.9 features. Python has been proven effective as well as simple. High-level data structure available in Python, when coupled with the dynamic semantics and syntax which is easy to understand, it becomes the most preferred development option for organizations developing web applications. Python language is the best choice for quick data analysis, web development, and scripting. Python constructs are very simple, and because of its simplicity and modular nature of programming, the reuse of Python code is pretty easy. This simplicity and code reuse help in minimizing the web development cost. Features like proper use of white spaces and code readability in Python has made Python one of the most preferred web development tool for professionals. But there are some drawbacks too. Python lacks in having built-in features for web development, and programmers need to use frameworks for web development. Python modules and packages help programmers develop website applications without worrying about process management. Some popular Python web frameworks. There is a wide variety of Python frameworks for web development, and some popular ones are described here. Django. This is open source web development framework with full-stack web development features. This most popular framework is very fast and easy to use. The developers can develop complex applications quickly with a great scope of flexibility. To streamline the process of web application development, the Django framework supports the use of pragmatic designs and makes it even more useful. At present, Django is possibly one of the best Python web development frameworks. Django is full of amazing features, and this is the reason that it is so popular when compared with the other Python frameworks available in the market. Some of its best features are an authentication mechanism, content administration, template engine, URL routing, and database schema migration. Above all, Django supports most of the popular databases like Oracle, MySQL, PostgreSQL, and SQLite. This support is critical for the implementation of high-traffic websites and web applications, and also some popular social media platforms like Pinterest, Instagram, The Washington Times, Bitbucket, Disqus, and Mozilla. Django can be considered one of the most reliable and most sought web development frameworks. Because of its incredible effectiveness, hassle-free development, less coding, and reusability of fewer components, the security and protection features of Django are excellent, and it ensures that the programmers steer clear of any kind of common security mistakes like cross-site scripting, clickjacking, SQL injection, and forgery. Some of the highlights of Django are rich in features, high-speed database interface, security, versatility and scalability. Bottle framework. Bottle framework is very small in size, and it is primarily used to program web APIs. It is a micro-framework popular for its minimalistic features. Though it is very small in size, its performance is not affected by its small size. Because of its small size and better performance, it is one of the most preferred web development platforms. In the Bottle framework, the developed web application gets executed using a single source file without having any dependency on other source files. There is an exception for Python standard library. The Bottle framework is quite simple and pretty fast at the same time. There is adapter support if a developer wants to use third-party template engines or WSGI HTTP. In short, Bottle is a simple and minimalistic web development framework which can be useful in building web applications for personal use. It is an ideal framework which assists in exploring and figuring out the organization of web frameworks and prototyping, and it is most suited for building various types of RESTful services. The best part of the Bottle framework is that it helps the developers to work closely with the hardware, and this is one of the reasons behind its use in Netflix OTT for its web interfaces. Here are some of the highlights of Bottle: minimalism, pretty small size, easy access to form data, cookies, HTTP metadata, and file upload, URL parameter support for building requests that dispatches routes, excellent database plugins support. Pyramid framework. The Pyramid is a popular full-stack web development framework, and it is one of the go-to options available for web developers for a long time. The framework follows very high standards, and it is capable of making decisions which are usually made by programmers. For this, programmers need to provide a well-defined viewpoint of the framework. Based on this viewpoint, Pyramid framework functions and makes decisions. If someone is keen on learning the best Python frameworks, then the Pyramid framework is the best choice because of the plethora of benefits this framework offers. The Pyramid framework makes a series of decisions until the web application grows. Once significant growth is achieved, the framework stops making decisions. The main target of this framework is to develop the best web applications with minimal resources and less complexity. The framework is well suited for various types of web applications and ideal for creating content management systems, CMAs. It is also an ideal choice for building API projects and prototyping. The best part of the pyramid framework is its lightweight structure and the capability of supporting the development of different kinds of web applications with utmost transparency and simplicity. Another positive aspect of this framework is its excellent support for security needs like authorization and authentication. The pyramid security features are highly reliable. It simplifies the application setup and assessment process. Developers can also use third-party resources with this framework. Highlights of the pyramid are function decorators, single-file applications, URL to code mapping using traversal framework, predicates and renderers, Flask framework. Flask is another micro-framework for Python, and it is available under the BSD license. Sinatra Ruby framework is the main inspiration behind the development of the Flask framework. It is dependent upon Jinja 2 and Worksion WSGI toolkit templates. The main idea behind this Flask is to build a robust web application foundation. Once the foundation is ready, a developer can make use of extensions to build the application. The Flask framework can be used for the development of any type of web application. Some of its highlights of Flask are integrated support, Unicode-based, ability to plug in the ORM, CherryPy framework. CherryPy is a lightweight and efficient Python framework. It is another minimalistic micro-framework. This Python framework makes web development tasks easy and development is quite similar to an object-oriented program. The main idea behind the evaluation of the CherryPy framework is to make it extensible. This framework has a concept of hook points and extensions. The CherryPy-powered web applications are standalone web applications and they can embed their own multi-threaded servers. The web applications developed using CherryPy can run on all popular operating systems. Some of the highlights of CherryPy are: it has powerful configuration system, built-in support for the profiling, testing, and coverage, flexible plugin support. It is pretty simple and supports multiple HTTP servers at once. Hug framework. The Hug is a popular API development framework on Python 3, where developers can create an API once and use it wherever needed. This framework simplifies the development of APIs by making use of various types of interfaces. The Hug framework is one of the fastest and most efficient frameworks available in Python 3. Highlights of Hug are automatic documentation support, Python compliance, can also be used in Python libraries, built-in version control features, Falcon framework. Falcon framework is a micro-framework designed to build Python APIs quickly. It is quite popular and is a widely used Python framework. While developing HTTP APIs, the Falcon framework need not load a large number of dependencies. Falcon supports a cleaner design of the APIs and supports HTTP and REST architecture. Highlights of Falcon are support, full Unicode support, Python support, URI templates. Which Python framework can choose for web development? There are many popular Python frameworks available for web application development. It becomes difficult to select the right framework for a development project. The best way to select the right framework is by taking the project size, requirement, and scope into consideration. 1.11 Summary. Web application architecture is a model that demonstrates how web application components interact with each other. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.